I want to show you some 12 basic rules that you can apply when solving indices problems. Let us begin immediately. Rule number 1. N to the power of A multiplied by n to the power of B is the same thing as n to the power of A plus B. An example is 2 to the power of 3 multiplied by 2 to the power of 2 is exactly the same thing as 2 to the power of 3 plus 2, and this is 2 to the power of 5, or you can simplify it as 32. Example number 2, or rule number 2 rather. N to the power of A divided by n to the power of B is the same thing as n to the power of A minus B. An example of this is 3 to the power of 5 divided by 3 to the power of 2 is the same thing as 3 to the power of 5 minus 2. When further simplified, this is 3 to the power of 3, and it can be written as 27. This is the answer. Rule number 3. Rule number 3 states that n to the power of A plus the bracket all to the power of B is the same thing as n to the power of A times B, which can actually be expressed also as n to the power of AB. How does this apply in indices? Let me give you an example. In brackets, 2 to the power of 2 or 2 squared all raised to the power of 3 is the same thing as 2 to the power of 2 times 3, which is exactly the same as 2 to the power of 6. And when further simplified, this can be written as the number 64. This is how this rule applies. Let me show you number 4 rule. The fourth rule of indices gives that m and n all to the power of A is the same thing as m to the power of A times n itself to the power of A. How can you apply this? Take an example as 2 times 3 all to the power of 2. This is the same thing as 2 to the power of 2 multiplied by 3 to the power of 2. This is the same also as 2 squared is 4 multiplied by 3 squared is 9, which is the same as 36. This is how you can apply. Rule number 5. The fraction m divided by n all raised to the power of A is also the same as m to the power of A divided by n to the power of A. How can we apply this? Let's apply it immediately. 3 divided by 4 all raised to the power of 3 is the same thing as 3 raised to the power of 3 divided by 4 raised to the power of 3. If we further simplify this, 3 raised to the power of 3 is 27 and 4 raised to the power of 3 is 64. This is our answer. It's as simple as that. Now, what is rule number 6? Rule number 6 is what I call the negative power rule. N raised to the power negative A can be expressed simply as 1 divided by n raised to the power A. A simple example is 4 raised to the power negative 2 is the same thing as 1 divided by 4 raised to the power 2, which when simplified is going to be 1 all over 16. Now, let's look at rule number 7. Rule number 7 says that the square root of n can also be expressed as n to the power of half. An example is the square root of 4 is the same thing as 4 to the power of half, and 4 to the power of half, as we know, is 2. It simply means the square root of 4. Now, let's dig in a little further. Rule number 8. The 8th root of n can also be written as n raised to the power 1 over a. Note here that a is never equal to 2. With that in mind, let me give you an example. An example is the third root of 27. This can further be expressed as 27 raised to the power of 1 over 3. And as we know it, the third root of 27 is exactly the same thing as the number 3. This is our answer. Okay, I think I should change my color this time around so that my ink can change. Now we go to rule number 9. Rule number 9, let's use the bit root of n all to the power of a, or this can actually be written like this with a bracket the bit root of n, close the bracket, all to the power of a. An example is the third root of 8, all to the power of 2. So let's close it in a bracket and square it. As we know, the third root of 8 can actually be written this way. Now, we can further simplify this rule as exactly the same thing as n raised to the power a divided by b. So, for the third root of 8 raised to the power 2, this is exactly the same thing as 8 raised to the power 2 all over 3. And as we know, the third root of 8 is 2. Then, this is now going to be 2 raised to the power 2. And 2 raised to the power 2 is equal to 4. Did you get that? Alright, we have just a few more to go. So, let's proceed. Rule number 10. Rule number 10 is what I call the negative fraction power. N raised to the power negative a over b. This is further expressed as 1 divided by n raised to the power a over b. Let us show an example. Imagine having 27 raised to the power of negative 2 over 3. How would you solve this kind of problem? This is exactly the same thing as 1 divided by 27 raised to the power 2 over 3. Let's try solving this problem and see how we can actually simplify it. The numerator remains 1. Now, the third root of 27 is 3. Remember the 2 power, that is 3 squared. So our final answer is going to be 1 all over 9, just like that. Alright, the 2 remaining rules are what we call the special rules of indices. Rule number 11. Rule number 11 states that any number to the power of 0 is equal to 1. But note, in this case, the number must not be the same number as 0. Let me give you an example. 5 to the power of 0 is the same thing as 1. Yes. 2 to the power of 0 is the same thing as 1. Yes. 100,000 to the power of 0 is the same thing as 1. It's as simple as that. But most importantly, the number must not be 0 to the power of 0 because that doesn't work here. Did you get that? And finally, another special rule of indices. N to the power of 1 is the same thing as n. In fact, we usually do not show the number 1 when we're writing numbers. For example, instead of writing 5 to the power of 1, we simply write it as the number 5. It's as simple as that. Instead of writing 2 to the power of 1, we can simply write it as the number 2. This rule applies for every whole number as well, even 0 itself, because 0 to the power of 1 is also the same thing as 0. I hope you enjoyed our video today. Thank you once more for watching Whiteboard Math Party. Please give us a thumb up if you really enjoyed the video to encourage us to do some more. See you later. We have a question on the board to solve, and the question says express in index form. We have about 6 questions altogether, so let's swing into action immediately. The first question gives us 3 multiply 3 multiply 3 multiply 3. To express this in index form is really easy, because to multiply 3 4 places simply means write 1 3 because all the bases are the same, and put a 4 on it. That's it. 3 raised to the power 4. That's the answer. Another simple way to express something like this is simply to say 3. Since each of the numbers standing is to the power of 1, we're going to say 3 to the power of 1 plus 1 plus 1 plus 1 because there are 4 3's. That is also going to leave you with the same answer, 3 to the power of 4. So whichever way you do it, you will also end up having the answer 3 to the power of 4. That's it. Second one, 3 times 7 times 3 times 7. Watch something here. We have 3 and we have 3 here. I'm going to keep them close to each other as 3 multiply 3 times, and the 2 7's, I'm going to keep them close to each other. So it's going to be 7 times 7. Now, it's easy for me to know that there are 2 3's, which is 3 to the power of 1 plus 1 is 2. 3 to the power of 2, and 7 times 7 is 49. But I'm not going to write 49 since the question says we should write them in index form. So I'm simply going to write it as 7 to the power of 2, or 7 squared. This is the final answer because the question says express them in index form. So we have to leave the powers. You get that? Okay. The next question is the root of 17. Remember, we want to express this in index form. To do that, We mentioned that when we have a square root, another way to express it is using the power half. So 17 square root, or the square root of 17, is better expressed as 17 to the power of 1 over 2. It ends here, it doesn't go beyond that. That's the answer. Let's try out the next one. This is the square root of 2 to the power of 3. The same square root in 17. So first of all, I'm going to write 2 as 2 raised to the power of half. Close my bracket, everything is raised to the power of 3, something like this. And now if we simplify further, using the multiplication of powers, this is going to be the same thing as 2 to the power of half times 3. We're going to say this as a fraction, so I'm going to make it 3 over 1. Therefore, it is written as 2 to the power of 1 times 3 is 3, and 2 times 1 is 2. This is the final answer, since the question says you should express them in index form. Don't go beyond that. Alright, now let's solve this question. This is actually different. This is the fourth root of 3, which is different from the ones we've solved earlier. But if you also remember the power rule, you remember that we said when you have a root that is not square root, you express it simply as the power of nth root. And in this case, our n is 4. So I'm going to write the base, which is 3, and express it in the fourth root, which is 3 to the power of 1/4. It ends there too. Very easy, right? And here we come to the final question. 1 divided by 6 times 6 times 6, 6 in 3 places. If I further simplify this, first of all, this is 1 over 6 to the power of 3. But this is not the final answer because I have not actually expressed this as in index form. Therefore, to make this simple in index form, I'm going to apply a rule, which is the rule of negative power. We had mentioned earlier that when you have n to the power of negative a, it is the same thing as 1 divided by n to the power of a. So if you look at this situation, it is exactly what we have here. Therefore, I have to bring it to this situation by writing it as 6 to the power of negative 3. This has finally been expressed in index form as required. I hope you enjoyed this video. Give us a thumb up if you really did enjoy it. And please turn on the notification bell so that you can see some of our videos next when we upload them. Thank you for watching. Our job this time is to simplify the following expressions. They are all indices. So let's see how far we can apply the rules we've learned earlier to solve these problems we have right here. The first one is x squared times x to the power of 5. Very important, you should know that when x is squared, it simply means we're doubling x, right? So you can decide to make it x times x. That's what x squared means. And this we're multiplying by 5x's altogether. That is, remember this is multiply, okay? So this is going to be 1x, 2x's, 3, 4, 5. This is a very simple way of solving this kind of problem. So the very next thing I'm going to do to get my answer here is to count. So for me to count, I simply have to count 1, 2, 3, 4, 5, 6, 7. That's 2 plus 5, right? So it means that the total number of x I have is 7. So my answer is x to the power of 7. It's as easy as that. Another simple way to do it to make your work easy instead of counting is to simply say, since the bases are the same, x, I take it out, x. Now I add the powers, 2 add 5. So it's going to be that 2 add 5 is 7. So my answer ends up being x to the power of 7. This is as easy as that. You got it? Okay, let's try it out in the next example. The next example has a to the power of 6 divided, not multiplied this time, divided by a to the power of 4. So how are we going to do this? Now the only difference between this example and the first example we solved is the division sign. So we can also apply the same rule. I'll make it a bit easier for us, okay? So what I'm going to do, you can try working out a in 6 places like this. A, 1, 2, 3, 4, 5, 6. The points I'm writing in between them represent times, okay? Divide. one way of writing division sign is the fraction form all over, like this. Then I'm going to write the remaining one. A1, 2, 3, 4. Okay, now it's time to cancel out. Let's do the canceling process. Now I'm going to remove one up, one down. They go together. One up, one down. They go together. One up, one down, and one up, one down. Since I've removed all these, how many do I have left? I have just double A. That's A double. Okay, so I'm going to write A squared because I have A two places. That's it. That makes your work easy, right? But when you have very high powers, this method of counting becomes time consuming. And because we don't want to consume all our time, we try to apply the rules directly enough. So if I apply the rule directly enough, since it's division sign with exactly the same base, all I will need to do is simple. So I'm going to say A to the power of 6 minus 4. 6 minus 4. Remember, when you are dealing with division of the same bases with different powers or the same powers, it has to do with the same base and then subtract the powers. So my answer is going to be A to the power of 6 minus 4 is going to give me 2. So we end up having exactly the same answer. Let's try solving b to the power of negative 4, everything all together raised to the power of 3, or everything cubed. Okay, if we decide to work with the powers we have here, first of all, it simply means we are going to do with b to the power of negative 4 three places. This is what I mean. B to the power of negative 4 one place times b to the power of negative 4 the second place times b to the power of negative 4 the third place, right? Yeah, that's how it's going to be because we have applied similar thing here. So if that be the case, it's time to add them, right? We're going to add b to the power of negative 4 plus b to the power of negative 4 plus b to the power of negative 4 the way we added them earlier. So if we apply our knowledge of addition of negative numbers, I'm going to say b to the power of negative 4, add negative 4 again, add another negative 4, right? So how is it going to be? Addition of negative numbers is simply the total addition of the numbers in a negative form. So my final answer is going to be b to the power of negative 4, 1, 2, 3. It's simple. It's the same thing as negative 12. I can leave my answer this way, or I can choose to take it a little further by simplifying this because this is negative power rule can be applied here, right? So if I go further, I can leave it as 1 divide b to the power of 12 without writing the negative number. You can leave your answer like this. You can also write it this way. Since 1 to the power of anything remains 1, you can write it 1 divide by b, close the bracket, everything raised to the power of 12. It's also the same answer. Yeah, it's the same because if you express 1 to the power of 12, it remains 1. While b to the power of 12 remains b to the power of 12. So if you write your answer like this, you're correct. You write it like this, you're correct. You write it like this, you're correct. Then there is another way to solve this problem to make it easy for you instead of going through these rigorous processes I've just gone through. Let me show you what I mean. Let me use red this time to differentiate, okay? So instead of going through this long process, you can simply say you're solving this by saying b to the power of negative 4 multiplied by 3. Yeah, this is multiplying two powers together. And if I do that, it leaves me with b to the power of negative 4 times 3 is negative 12. Your answer comes back. And you can choose to express it this way or this way. Whichever way you choose to leave it is your choice. But the most important thing is that you know what you're doing, right? It depends on what the question requires you to do. Now, this is the connection between the left-hand side and this side, right? So it's still the division that we did in the previous question that we just solved. So what I'm going to do now is, first of all, this is going to make my numerator. So I'll make it this way, minus 5x to the power of 4, y to the power of 6. This is my division sign like this. And my denominator is negative 10x to the power of 3 upon 2 and y to the power of negative half. Yeah, something like this. This is a good step to start. Now I'm going to make my work easy somehow. See the way I'm going to make it. There is up, there is x up here, there is x down here, there's y up here, there's y down here. See, I'm just going to separate the numbers together, the x's together, the y's together somehow. So I'm going to do something like this. Negative 5 over negative 10, they can stay together. then times x to the power of 4 divided by x to the power of 3 upon 2. They can stay together, times y to the power of 6 divided by y to the power of negative 1 upon 2. They are still together, right? So we are going to apply the simple division rule that we already know here. So see what I'm going to do. For this case, if I want to divide, negative cancels out negative. So I have 5 upon 10. If 5 cancels out 5, I have 1. 5 cancels 10, I have 2. So I have half. I'm writing it down. 1 upon 2, multiply. Now see, I'm going to apply the division rule here. So it's going to be, take the same base, which is x raised to the power of 4 minus 3 over 2. You minus when you are dealing with division, okay? And times, this case, the base is the same as y. So I'm going to raise it to the power of 6 minus negative half, like this. Okay, so let's solve it out. This is going to make our work easy. Half remains half. I'm going to write it a bit bigger this time. Okay, half times, let's do this. This is a fraction we're going to simplify. So it's going to be x to the power of 2 times 4 is 8, and 8 minus 3 is 5. So it's going to be x raised to the power 5 over 2. Yeah, times y to the power of, let's simplify this. Negative multiply negative is plus, right? So if you want to simplify this, it's going to be 2 times 6 is 12 plus 1, right? So 2 times 6, 12 plus 1 is 13. It's going to be 1, 3 all over 2, something like this. So I can express my final answer this way. I can simply say my final answer is the same thing as, let me write it here. I'm going to do it with a different color since this is my final answer. Let me write with a dark blue or just a light blue. Okay, light blue is okay. I'm going to write it as half, okay, x to the power of 5 over 2 and y to the power of 13 over 2. If you leave your answer like this, you are very correct. No problem with that. Perfect. Or you can also decide to express it this way. I'm going to write it in fraction form. So if I want to write it in fraction form, 2 is going to be our denominator. As you can see right here, why everything is a numerator? Because I'm multiplying 1 by x by y, right? So 1 multiply x and y together remains x and y. Therefore, I'm going to write like this. X to the power of 5 over 2 times y to the power of 13 over 2. Yeah, everything is all over 2. This can also be my final answer. So if you keep it this way, you are perfectly correct. And if you keep it this way, you are also perfectly correct. I hope this video has helped you to understand how to apply the rules that you learned earlier on how to operate indices. Give us a thumb up, please, like this video, and turn on the notification bell so that when we upload our next video, you'll be the first to see it. As always, thanks for watching. Alright, this time we have a responsibility of simplifying these two questions. They look like they are a bit tough, but don't worry. When we solve them, you will see the little tricks we are going to apply to make the work easy for us. Welcome to Whiteboard Math Party. If you've not subscribed to this channel yet, please do so today. You will enjoy it. You will never regret it, trust me. Okay, let's begin. First of all, let's solve the first problem that says we should simplify this mighty fraction right up here. So begin this way. Looking properly at this question, you see that almost everything is in the power of 2. So what I'm going to do is, for that numerator where I have 4, I'm going to change it in the power of 2. So instead of writing just 4, I'm going to express it this way. 2 to the power of 2. Yeah, that relieves me a bit. And you know what? This 2 to the power of 2 is exactly multiplying whatever is inside this bracket. So I'm going to write it as 2 to the power of 2 multiplying 2 to the power of n plus 1, right? Yeah, that's n plus 1. Minus 2 to the power of n plus 2. Minus 2 to the power of n plus 2. Okay, that's my numerator as usual. Why my denominator? I can express my denominator the same way it is anyway. So I'll just leave it as 2 raised to the power of n plus 1 minus 2 to the power of n. Okay, let's take it a bit further. This time around, what I'm going to do is, since I have 2 and 2 the same base, I'm going to work them together, right? So what I'm going to do is simple. I just have to take I'm working out this part and this part together now. So I take one of the bases, which is 2, and I add the powers. So if I add the powers, it's going to become n plus 3, or 3 plus n, you know. I did this because 2 add 1 is 3, and this is the n, so that's n plus 3. Minus 2 in the power of n plus 2, still on my numerator. All divide by, yes, look at the denominator. There is something I can actually do here. Since I have 2 to the power of n plus 1 and 2 to the power of n, I can factor out 2 to the power of n and simplify what's left. So if I factor out here 2 to the power of n, open bracket, how much do you see here? See, this is 2 to the power of n times 2 to the power of 1. That's what gave us this value. So it means if I leave 2 to the power of 1 inside the bracket, 2 to the power of n times 2 is going to give me 2 to the power of n plus 1 because the power here is 1, which is exactly here, factored, right? Minus 1. It's minus 1 because I just need to replicate 2 to the power of n here by multiplying 2 to the power of n by 1, right? Okay, since you've understood this level, now watch the numerator. I can simply factor out something on the numerator also. So I have 2 to the power of n plus 3 here. I have 2 to the power of n plus 2 here. I can work with 2 to the power of n plus 2. So if I do that, I'm going to go with 2 to the power of n plus 2 as my numerator. Open bracket. What do I have to multiply here? I simply need to multiply 2 to the power of 1 because 2 plus the power 1 will give me 3, which is exactly what I have here. So I'm leaving it this way since the power of 1 is not expressed. Minus 2 to the power of 2 times 1 will leave me with 2 to the power of 2, which I already had. So I just write 1 here. All divide by, now let's simplify the one we've done before. It's going to be 2 to the power of n alone because 2 minus 1 is 1. And 1 times 2 to the power of n leaves you with 2 to the power of n. Nothing else at the denominator. So let's proceed. It's getting easier, right? For the numerator, 2 to the power of n plus 2 is still there. 2 to the power of n plus 2 is still waiting for us. 2 minus 1 is 1. So 1 times 2 to the power of n plus 1, sorry, n plus 2 remains the same. So we're leaving our numerator as 2 to the power of n plus 2, while our denominator is 2 to the power of n. Now watch it. Here we have exactly the same basis, which is 2 and 2. So we can apply our division rule. In that case, it's going to be 2 to the power of n plus 2, which is at the numerator, minus, remember when we are dividing, the powers are subtracted, so minus n. If we do that, this n is going to minus n. That will be 0. So we're left with 2 to the power of 2, which I'm going to write here. You can leave your answer as 2 to the power of 2, or you can further simplify it as 4, because 2 to the power of 2 is 2 times 2, which is 4. This is the answer to this big question here. I hope you enjoyed this one. Now let's try number 2. Number 2 question says, if x to the power of 3 upon 4 multiplied by the square root of y over s multiplied by y to the power of 5 upon 8 can be expressed as x to the power of m y to the power of n, find n to the power of m. Well, this looks a bit bogus, but I'm going to make it easy, so don't worry about that, okay? Let's focus our attention right here. What I'm going to do is just a way of simplifying. So see what I'm going to do here, okay? I will start first of all by replicating what's up there. X to the power of 3 upon 4, yes. Now, it's the same as I'm multiplying here. I'm going to simplify this. A big square root covering y and x together can further be simplified as y over x, both of them raised to the power of half. This makes your work easy, right? Now, since I already did this, I just go for that to write this down, times y to the power of 5 upon 8. You would notice that all I'm trying to do is to simplify my problem, and when I simplify it, that is going to make my work quite easy. Please, this denominator here is x, don't get confused, okay? X, okay. Now, having done that, it's getting easy. I want to simplify whatever is in this bracket before I proceed. So, I replicate again. X to the power of 3 upon 4 times my numerator here now is going to be y to the power of half, divide by the denominator becomes x to the power of half. I have shared the powers for them, right? Now times y to the power of 5 upon 8. It's getting easy. Now my work is going to be this. Since this is a numerator on its own, I can express it as x upon 1, y I express this as y upon 1. I want them to mingle. Let the x go close to its brother and let the y go close to y so that my work will be easier. In that case, it's going to be something like this. I'm going to make it x now to the power of 3 upon 4 divides x to the power of half times y to the power of half multiplies its brother y to the power of 5 upon 8. Yes, the work is getting easier now. Now, this is division. I'm going to apply the division rule to this part. And if I do that, it's simply going to become x to the power of 3 upon 4 divided by x raised to the power 1 upon 2. So, using the division rule, I'm going to make it minus now. We subtract the powers since the bases are the same, and multiplied by y. Here, I'm going to apply the multiplication rule. Since the bases are the same y, I just have to add the powers half and 5 upon 8. My work is getting much easier. In that case, we'll end up having this answer, which I'm going to write down here. In that case, we'll end up having this x still at the base, 3 upon 4 minus 1 upon 2. Use your fraction rule. This is the same as 2 upon 4. So 3 minus 2 is going to give me 1 upon 4 here. 1 upon 4 times y raised to the power of, if I simplify this or make it equivalent to a denominator 8, this is same as 4 upon 8. So 4 plus 5 is 9. I have this as 9 upon 8. Okay, this has been simplified already to the barest. Since we are here already, remember that the question says everything is equivalent to x to the power of m and y to the power of n. Now, this is x, this is x. Our m is represented by 1 upon 4, while our n takes the position of 9 upon 8. So to find the value of n raised to power m, I'm going to use a different color to do this so we don't get too much confused. All right. So what I'm going to do now, for n to the power of m, since we already know what each value stands for, it's going to be the same thing as, since my n is the same thing as 9 upon 8, all right, 9 upon 8, close the bracket, to the power of m. What's m? M is 1 upon 4. Okay. So if I make this to become 3 to the power of 2 for 9, close the bracket, raise it to the power of 1 upon 4, because 1 upon 4 is the fourth power, which you see here. Divide by, can we simplify 8? Let's see if we can do that. 2 to the power of 3 is 8, which we can also express in the power of 1 upon 4. So if we further break this down, 2 is going to cancel 2 here, so you have half, which is 3 to the power of half, 3 raised to the power 1 over 2, all over 2 to the power of 3 over 4, 2 to the power of 3 over 4. You can leave your answer like this, or if the question requires you to do more, you can express this as square root of 3 all over the fourth root of 2 to the power of 3. Whichever way you write your answer, either this or this, both of them are correct. Please give us a thumb up if you enjoyed this video, and thanks for watching. This question appeared in the JAMS University Matriculation Examination Mathematics in 1990. It is from the topic Indices. And to read the question, it says, simplify the square root of 160 r squared plus the square root of 71 r to the power of 4 plus the square root of 100 r to the power of 8. Looking at the question, we can see vividly that 100r to the power of 8 is covered by 3 different square roots, while 71r to the power of 4 is covered by 2 different square roots, and 160r squared is covered by 1 square root. So, how do we solve this kind of problem? Well, this is just like the same problem I solved a few days ago on fraction. The question also came from the same exam body. So, a strategy you can apply to solve this is to do it in bits. So, let's solve it and see what you can do to be able to dissolve this. I'm going to begin by solving the part that requires the square root of 100 r to the power of 8. So, to rewrite this part of the question, I can write it simply as 100 r to the power of 8 and close the bracket raised to the power of half. Mathematically, the power of half is another way of writing square root. So this is going to help me. Now if I simplify this expression, the square root of 100 is 10 because 10 multiplied 10 is 100. Now to simplify r to the power of 8 and all in a square root, I simply have to divide this 8 by 2, that gives me a 4, while the 2 is cancelled out, and 4 multiplied 1 is 4. So this leaves me with r to the power of 4. Now if you look at this, we have emptied out the first square root. If I decide to rewrite this part of the question right now, it's going to be something like this. It's going to be the square root of 71 r to the power of 4 plus 10 r to the power of 4. Now, to work this out, know that the r's have exactly the same power, 4. So we can add them together, and that's going to give us the square root of 81 r to the power of 4. Now to simplify this, I'm going to apply similar approach that I had used earlier while I was trying to simplify 100r to the power of 8, which is using our power idea of indices. I'm going to rewrite this as 81 r to the power of 4 and close it in a bracket and raise it to the power of half altogether, where half serves as our square root sign. In that case, first I'm going to look for the square root of 81. That's going to give me 9 because I know vividly that 9 times 9 is 81. That is solved. The next thing to be done here is to divide the power 4 by 2, and that's going to give me 2. 2 times 1 leaves us with 2. So we're having here r squared. Now we have successfully simplified the second bracket along with the third one. But this time around, to include 9r squared to what is left in the bracket, this will mean that we have 160 r squared plus 9r squared. Both of them are being held by one square root. So let's simplify this and see how to work out the answer to this problem. If we proceed with this, because both r's have exactly the same power of 2, we can add these two expressions together. So 160 r squared add 9 r squared is going to leave us with 169 r squared. Remember, the number is in a square root. All right, this is getting interesting. We can choose to work it out using a bracket like I did before, or we can go this straight away because it's far much simplified. The square root of 169 is 13 because 13 times 13 gives us 169. While the square root of r squared is simply going to give us r because the square itself can be cancelled out by the square root. And this is the final simplification we can give to this problem. Hence, we will say that this full set of expression given in this square root ends up with the answer 13r. Can you try solving it with your method and let us know if you have a simpler way to do this kind of problem? As always, thank you for watching Whiteboard Math Party. If you have not subscribed to this channel, please do us a favor by doing that and turn on the notification bell so that you can receive more of our updates in the future. Thank you and see you soon. Our responsibility here is to find the values of x for these two questions that we are given to solve. The first one is 8 to the power of 1 minus 2x is equal to 1 upon 4 to the power of x. So let's begin by working out 8 in the power of 1 minus 2x is equal to, here is exactly the same thing as 1 upon 4 all to the power of x. So you should know that, all right? With that in mind, we can do something like this. This is going to be 8 in the power of 1 minus 2x is equal to, for this part, I can express it as 1 over 2 in the power of 2, close the bracket, all raised to the power of x. 8 is the same thing as 2 to the power of 3, right? So I'm going to work with 2 to the power of 3 multiply 1 minus 2x on the left hand side. While on the right hand side, 1 divided by 2 raised to the power 2 can be written as 2 to the power of negative 2. So I'll be multiplying negative 2 by x in my next step. Let's open up this bracket. This is the same thing as 2 to the power of 3 times 1 is 3 minus 3 times 2 is 6. Remember your x. This is on the right hand side equal to 2 to the power of negative 2 times x is negative 2x. Now when you get to this level, the rule that applies here is equality of base. This base and this base are actually equal, so we can cancel them out and work out the powers as the new base. Therefore, our new equation is 3 minus 6x is equal to negative 2x. Okay, I'm going to collect like terms by taking negative 6x to the right to make it positive. So this becomes 3 is equal to positive 6x minus 2x. And if we solve this further, I have 3 equal to 6 minus 2 is 4. So we have 4x on this side. Dividing both sides by the coefficient of x, which is 4, means I will have 3 over 4 on the left hand side and 4x over 4 on the right hand side. This leaves me with 3 over 4 for x. 3 over 4 is equal to x. Therefore, our x is exactly the same thing as 3 over 4. Okay, the value of x has been found for the first equation. I can actually express 10 to contain 5. So 2 times 5 is going to give me 10, right? Let me do that first. 2 times 5 is the same thing as 10. So I leave it as this. Okay, multiply by 5 in the power of 2x minus 2 times, watch this guy, I can express it as 2, so I will have a fellow to work together with 2. So I'm going to leave this as 2 in the power of 2 times x minus 1. Close the bracket, everything is equal to 1. I think we are progressing so speedily. Now, using the rule of same power when multiplied, this is going to be 2 to the power of x times 5 to the power of x times 5 to the power of 2x minus 2 times 2 to the power of 2x minus 2 also. Everything is equal to 1. Wow, we are progressing. Now work it out together as a way of collecting like terms. Let the 5's go together. So for the 5's, I'm going to do something like this. 5 alone to the power of x plus 2x is going to give me 3x minus 2. Yes. Times, what about 2? I'm going to work with this guy here and this guy here. Let me change the color for the 2's so that we don't get confused. So it's going to be 2 here, all right, in the power of x plus 2x is going to give me 3x minus 2. Okay, all is equal to 1. Now it's decision time. What exactly do we intend to do with the 1 this way? Watch the power of 5 and watch the power of 2. They're exactly the same. So we can go back to express them in this form, which we did earlier. Therefore, I'm going to say we're having 2 times 5 or 5 times 2, whichever way you want to express it. 3x minus 2 is equal to 1. We are progressing. Now 2 times 5 gives you 10. So 10 is the same thing as 10 raised to the power 3x minus 2 is equal to 1. Remember the rule of the power of 0, where we said that any number raised to the power of 0 is equivalent to 1. To work this out, a better number to select is 10 because I will have to cancel out the base together. So I will express it further as 10 to the power of 3x minus 2 is equal to 10 to the power of 0. In that case, I can confidently cancel out the bases. So our new equation becomes 3x minus 2 is equal to 0. Solve this out. 3x on the left hand side is equal to positive 2 on the right hand side. I will divide by the coefficient of x, which is 3. And when this is done, you notice that our final answer x is equal to 2 upon 3. I hope you like how swift we solved this problem. You can try pausing the video along the line and try to solve it to see if you'll be able to do the same. Thank you for watching for the first part where we have 5 to the power of x minus y. See, I can actually express 125 as 5 to the power of 3. So I can do something like this. 5 to the power of x minus y is equal to 5 to the power of 3, which is 125. And if I break this down by removing the powers, you see that I'm left with the equation x minus y is equal to 3. We can decide to call this our first equation, which is equation 1. Before we can proceed, now we're going to look at this part. And to look at this part, it is going to involve us expressing 243 in the powers of 3. And if you check your 3 to the power of 5, that gives you exactly 243. And in that case, we can write it as 3 to the power of 5. This is what I mean. For 3 raised to the power of 4y minus x, I bring it down here. 3 raised to the power of 4y minus x will now be equal to 3 to the power of 5. Now notice that the bases have become the same. So I can cancel them out and I'm left with 4y minus x is equal to 5. This can be seen as our second equation, equation 2. Now that we have a simultaneous linear equation already in hand, we can solve for the values of x and y using any of the methods of solving simultaneous linear equations. For now, I'm going to use the substitution method to do that. So let's get the party started. Now, from equation 1, you would notice from equation 1 that I can simply say x is exactly the same thing as y plus 3 or 3 plus y, whichever way you choose to write it. So I'm going to substitute the value of this x, which is equal to y plus 3 into equation 2. And in that case, the equation 2 that we have will now change. It will now become 4y minus my x is going to take the place of y plus 3, okay? Because I'm substituting right here. So everything is equal to 5. Now let's solve this. This will be 4y minus y minus 3 is equal to 5. Collect like terms. 4y minus 1y is 3y, right? So 3y is equal to 5 plus 3 because 3 has to close. 5 plus 3. And when we do this, it's going to be that 3y is equal to 8. To get the value of y means to divide by 3, which is the coefficient of y. Therefore, our y is evidently equal to 8 upon 3. Okay, now that we've successfully found the value of y, which is 8 over 3, remember that we already said from equation 1 that x is equal to y plus 3. So I'm going to substitute the value of y into this equation. So I'm going to say something like this. Remember that x is equal to y plus 3. Hence, if I substitute this value, x will become 8 divided by 3, all add 3. Working it out fractionally in a fraction style, x now is going to become 3 times 3 is 9. So 9 plus 8 is 17. That leaves always 17 over 3. That is the value of x. So we have successfully found the value of x and the value of y. But that's not what we're looking for in this question. Remember from the beginning, the question said we should find the value of 2 to the power of x minus 2y. So to find the value of 2 to the power of x minus 2y, this is exactly what we need to do. 2 to the power of x minus 2y is going to leave us now with 2 to the power of, what's our x? 17 divided by 3. And what's our y? Our y is 8 upon 3, which is to be multiplied by 2. So it's going to be 2 times 8 over 3, like this. Okay, let's work this out. Now we have 2 to the power of 17 upon 3 minus 2 times 8 is 16. So 16 upon 3. Now it's easier to solve. So our final answer is going to be 2 to the power of 17 minus 16 is 1. So 1 upon 3. You can leave your answer exactly like this. Or you can further simplify it in root form, since this is the third root of 2. So you can write it as the third root of 2. Any of these is acceptable as the final answer. I hope this is clear enough. You can try working it out yourself to see if you've mastered it. Thanks for watching. I will start by opening up more of what I have in this bracket. That is to say, I will start by expanding the bracket. So to do that, I have 4 already, open bracket. This is 3 to the power of x times 3 to the power of 1. I hope you know that, but because the power 1 is not written, I'm going to keep it just that way. Have that in mind, it's going to help you a lot. And the next one is exactly the same thing as 3 to the power of x everything times 2, right? This is x times 2 is 2x. I'm trying to make it easy for myself, and then you come to see how this turns to a quadratic equation. Everything equals 27. Now that we have reached this level, watch what I'm going to do. I'm opening up this bracket just this way. 4 times 3 times 3 to the power of x minus, are you following this? To square this number simply means 3 to the power of x times 3 to the power of x, right? So you can leave it the way it is, or you can square it. It's your choice. All is equal to 27. The most important thing is you know the direction you are going to. Now watch. There is a thorn in the flesh, 3 to the power of x, which appears everywhere. So let us substitute any letter for it. So in this case, let us use let the letter y be the same thing as 3 to the power of x. This is very important, so you keep it safe. You're going to use it later, okay? If this is the case, any place we see 3x, let us put the value y. Now, 4 times 3 is 12, and 3 to the power of x will now become y. Minus y times y is equal to 27. Okay, I think this is going to help us. Therefore, at this stage, we have 12y minus y squared is equal to 27. This is a quadratic equation. So, let us arrange it properly and solve exactly the way it should be. We'll get our answer. Multiply everything with a negative 1. That gives us y squared minus 12y is equal to negative 27. Equating everything to 0, I'm going to come this way to make this happen. So, to make it work out, to look exactly like the normal quadratic equation, I'm going to bring 27 to the left-hand side. So, I'll have right now y squared minus 12y minus, no, it's going to be plus 27 is equal to 0. All right. Can we solve this problem using factorization method? Yes, we can do that, because I can simply express this as y squared minus 9y minus 3y plus 27 is equal to 0. At least 3 plus 9 is 12, so it works. So let's factorize. Y times y is y squared, y times 9 is 9y. Okay, let's work this side out. Minus 3 times y is 3y. Minus times minus is plus, so 3 times 9 is 27. Everything is still equal to 0. So since we already have our brackets same, let's factorize further. So we have y minus 9 in one bracket and y minus 3 in another bracket. All is equated to 0. So if you find the values of y, you end up having y is equal to 3 or y is equal to 9. So using the values y equal to 3 and y equal to 9, we are going to solve y is equal to 3 to the power of x. Don't forget that. So remember, we already said that y is equal to 3 to the power of x. But in this case, we found the values of y to be y is either 3 or 9, right? So what would be our value of x? To make this happen, in place of y, we write 3 to the power of x because we already substituted y for 3x. So we're bringing it back. Hence, we're going to say when we have a case of y equal to 3, it happens to be that 3 to the power of x will be the same thing as 3. And when we have a case of y equal to 9, we replace y with 3x to mean that 3x will be equal to 9. So let's solve this out. In this case, if we cancel out the powers, if we cancel out the bases, we're left with just 1 at the power here. So x will be equal to 1 on this side, and on this side, 3 to the power of x is equal to 3 squared, because 3 squared gives us 9. Therefore, we can confidently say that the values of x are 1 and what? Here we cancel this out and we cancel this out. It's going to be 2. So s is equal to 1 and x is equal to 2. So the values of x are 1 and 2. Or you can just say 1 and 2 like this. Now you see, we've ended up solving this problem successfully, where an indices leads us to quadratic equation. I hope you enjoyed today's video. Please give us a like, comment, and let us know what you enjoyed most about it.